China just announced a $66 trillion plan to mine the moon. And they're not talking about some distant dream. They've already started building the infrastructure to do it. By 2035, they'll have a permanent base. By 2045, full mining operations, extracting resources worth more than the entire global economy. What they're going after could power Earth for 10,000 years with clean energy. You're watching the biggest engineering project in human history unfold in real time. But before China can extract a single gram of that $66 trillion treasure, they had to find it first. The $66 trillion treasure. Deep inside the moon's South Pole craters, where sunlight hasn't touched in 2 billion years, lies something that could change everything. Helium-3. 1 gram of it produces the same energy as 40 tons of coal. The moon has 1.1 million metric tons of it just sitting there in the dust. Do the math, that's where the $66 trillion comes from. And it's not just theoretical. China's Chang'e missions spent years mapping exactly where it is, how much there is, and how to get it out. But here's what makes this insane. One space shuttle cargo bay filled with helium-3 is worth $3 billion in energy production. Clean fusion power. Nearly zero radioactive waste. The fuel source that could end the fossil fuel era overnight. And China didn't just confirm it exists, they've already identified which craters have the highest concentrations. They're not exploring anymore, they're surveying. There's water ice in those same permanently shadowed craters, rare earth elements scattered across the surface. Everything you need to build a self-sustaining operation. China looked at the moon and saw what everyone else missed, not a destination, but a gold mine that's been waiting 4.5 billion years for someone to show up with the right equipment. And that equipment? It's already being built. The infrastructure already in motion. China's not waiting. Chang'e 6 just returned samples from the far side of the moon, a world first that no other nation has pulled off. Chang'e 7 launches next to scout the exact mining zones. Then Chang'e 8 tests, actual resource extraction technology. This isn't a research program, it's a construction schedule. And every mission is a rehearsal for what comes next. By 2028, the International Lunar Research Station begins construction. The location's already picked South Pole Aitken Basin. The oldest, deepest impact crater on the moon. The place where all that helium-3 is concentrated. China's already positioned relay satellites around the moon so they can communicate with the far side continuously. They've designed the Long March 9 rocket specifically to haul 50-ton payloads to lunar orbit. The launch windows are locked in through 2045. But here's where it gets real. First habitat modules touch down in 2030. Mining robots arrive in 2032. Power stations go operational in 2033. By 2035, people are living there permanently. This isn't NASA's "we'll figure it out when we get there" approach. China's following a blueprint. Every module fits together. Every mission builds on the last one. They're not exploring the moon, they're colonizing it. And the technology they're using? It's already solving problems that seemed impossible. The technology that makes it real. Mining on the moon sounds simple until you realize the temperatures hit -280 degrees Fahrenheit in those craters. Total darkness for weeks at a time. Dust so fine, it destroyed Apollo equipment and got into everything. China looked at every problem that made lunar mining impossible and solved them one by one. Autonomous mining robots that operate in absolute darkness using ground-penetrating radar. In situ resource. Utilization, that's the fancy term for living off what's already there. You don't ship concrete from Earth. You use lunar regolith, 3D printers that turn moon dust into building materials. Small nuclear reactors compact enough to fit on a lander but powerful enough to run an entire mining facility 24/7. Then there's the breakthrough everyone missed, the dust problem. Apollo astronauts couldn't figure out how to keep lunar dust from wrecking their equipment. It's electrostatically charged, sticks to everything, never comes off. China cracked it with electrostatic shields that repel the dust before it makes contact. They've been testing lunar soil processing plants on Earth for 3 years now, heating regolith to extract resources, separating water ice into hydrogen and oxygen. Every gram of lunar ice becomes rocket fuel made on the moon. Here's what that means. After the initial setup, every single mission gets cheaper. You're not hauling fuel from Earth anymore. You're making it there. And ready? Really? Really? The moon becomes its own gas station, and once you can refuel on the moon, you can go anywhere. But getting the helium-3 out of the ground, that's where the real engineering begins. The helium-3 extraction process. Helium-3 doesn't exist in veins or deposits you can just dig up. It's embedded in the lunar regolith, the dust and rock covering the surface. Billions of years of solar wind bombarding the moon left it there, atom by atom. To get it out, you have to heat lunar soil to 600 degrees Celsius. The helium-3 releases as a gas. You capture it, compress it, store it. 1 square kilometer of lunar surface, just the top 3 meters, contains 220 pounds of helium-3. China's mining robots are designed to do this continuously. Excavate the regolith, feed it into mobile processing units, solar furnaces using concentrated sunlight to superheat the material. The extraction facilities are positioned in areas with near constant sunlight, the peaks of eternal light where the sun barely dips below the horizon. No stopping. No downtime. Then came the part that makes this economically insane. They've designed a transport system to move processed helium-3 from the mining sites to launch facilities. Automated rovers running on tracks. Cargo containers that slot directly into return spacecraft. The whole operation runs like an assembly line. First shipment projected for 2046. 25 tons of helium-3, worth $75 billion. But here's the number that changes everything. By 2050, China projects annual extraction of over 100 tons. That's $300 billion worth of clean energy every single year. And they're not stopping there. Because once you can mine the moon, why stop at just sending resources back to Earth? The self-sustaining lunar economy. Phase 1 was always about extracting helium-3 and shipping it back to Earth. But China's not thinking in phases, they're thinking in generations. Phase 2 is where it gets wild. Manufacturing on the moon. For Earth, low gravity, no atmosphere. Conditions you can't replicate anywhere on our planet. It's not just a mining operation, it's a factory. Rare earth elements get processed on the moon, and finished products get sent back. Solar panels manufactured without atmospheric interference. Perfect vacuum conditions mean perfect production. Spacecraft components built in lunar shipyards where gravity is 1/6 of Earth's. You can construct things there that would collapse under their own weight. Here, China's already testing agriculture modules to see if they can grow food in lunar gravity. Because if you can feed people there, they never have to leave. But then the projections get even crazier. Phase 3 isn't about Earth at all. It's about using the moon as the construction yard for deeper space missions. Build the ships there, fuel them there, launch them from 1/6 the gravity. The moon stops being a destination and becomes the gateway. By 2060, China's projections show the lunar economy generating $500 billion annually. Not from tourism, not from research grants, from actual industrial production, mining, manufacturing, export. The first permanent population estimate? Over 100 Chinese citizens living and working there full-time. Not visiting, living. And this is where the $66 trillion number stops being about helium-3 and starts being about something much bigger.